Okay, here we are with the third exam from the fall 2012. Problem 1 deals with a force and distance graph. We're given that the 3 kilogram cart starts moving at 4 meters per second, subjected to this force. Determine the distance d, so the final speed after the force is 6 meters per second. Okay, anytime we have a force distance graph, we should recognize that the area in the graph is the work. Okay, so that's a basic concept. Force distance graph area gives us work. We have conservation of energy. We would have some initial kinetic energy plus some work equals some final kinetic energy. So I'll just write it like that. Okay, we have 1/2 mass, 3 kilograms. Okay, its initial velocity, 4 meters per second, plus work. Okay, that's the area. Okay, we'll calculate the area as it's a triangle, 1/2. The base is d, it's our unknown, that's what we're going to solve for, and the height is 12 newtons. Alright, so we'll write that in here, 1/2 d, 12 newtons, and that's our final kinetic, equal to our final kinetic energy, 1/2, 3 kilograms. And we want our final velocity of 6 meters per second. Alright, so now it's just a matter of solving this equation for d. So, like all the other videos, I will do that. Okay, I'm going to use a solver, even though it's not that hard of an equation. Lets me type it in exactly like I see here. So I'll get my solver reset, basically move this over to the other side. So I'm going to have 0.5 times 3 times 4 squared, this term, plus 0.5 x I'll use for d, times 12. And then moving it to the other side, 0.5 times 3 times 6 squared. Okay, double check my equation, that looks good. Solve, x equals 5, or d equals 5. Okay, the units, if I look at my units here, let's see, comes from this term right here. Every term in this equation has to be units of work or energy. So this is Newton meters, kilogram meter squared per second squared is equivalent to a Newton meter. So our d is going to be in meters. Alright, so simply 5 meters is our answer. 5.0 if you wish. That's that solution.